Welcome to another lecture in the series of engineering chemistry. We started part one and we are still on part one, and we've already had two lectures of part one. So this is lecture 3. So I'm going to recommend that you check the channel and watch the two lectures, lecture 1 and lecture 2 that we've had. So for lecture 3, we're going to continue from where we stopped. We want to move to bonding now. So before we go there, we want to see how Lewis structure is going to help us when we get to bonding. For example, for covalent bond, it's about sharing of electrons. And before you can know the electrons that are shared, you need to know the Lewis structure of the atoms that are involved. So we have two examples there. It's hydrogen and chlorine. So for the two examples, they are diatomic. So they're going to come together and form bond. For example, you can see this is a single bond and this is also a single bond. The reason why they're having single bond, we're going to get to it later in the lecture. So a quick reminder again, electrons on Lewis structure, we have lone pairs. These are electrons located only on one atom in a Lewis structure. We also have the bonding pairs. These are the electrons that you're going to represent in form of dots or one or line. So we're going to get to that also. So we have different type of bonds. We have in terms of the electron that they're going to share. So we're going to have the single bond, the double bonds, and the triple bond. For single bond, this is an example when one pair electron is involved in the bonding, then we have single bond. But when we have two pairs that is needed to be shared, then we're going to have double bond. Then when we have three bonds, that means that we're going to have more than two pairs involved in the bonding, and we're gonna have triple bond. For example, you can see this is CO2, carbon dioxide. So it's having a double bond to one oxygen, double bond to another oxygen, and so that's why we have double bond. And you can see that they are sharing two pairs of electron, and then we're going to have the double bond and double bond as you see it here. This is also nitrogen. So N2, nitrogen is also diatomic. You can see that nitrogen is using the three electrons that are now paired up to form triple bonds. Then the last example, you can see that carbon already gave one electron to hydrogen, form a bond with just one electron with the hydrogen here. Then the remaining three electrons for carbon, it's going to also form bond with the three electrons from nitrogen to give you triple bond. Then you have the lone pair electron on nitrogen. So let's do another step by step of writing Lewis structure. For example, we have this is phosphorus trichloride. So let's see how they're going to form together using Lewis structure. Remember from the electron dot structure that we did in our last lecture, you can see that phosphorus is going to have 5 electrons together. You're going to have one lone pair, then the rest are going to be single electrons. Then chlorine also is going to have this being paired, and then one. Remember that chlorine is going to have 7 electrons in its outermost shell. Phosphorus is going to have 5 electrons in its outermost shell. But for this compound, we're having 3 chlorine. So that means we're going to multiply the 7 electrons by 3. So if you add all the valence electrons together, it's going to give us 26 valence electron. 5 is coming from phosphorus, 7 times 3 is coming from chlorine, and that's going to give us 26. The next step is to begin to form the bond. So write the symbol for the atoms, then show which atom are attached. Then you can connect them with a single bond. So that means the one electron here for chlorine and the one electron here from phosphorus, they are forming one bond. So this one bond is representing two electrons. Same thing for this and the same thing for this. That means we have already used how many electrons altogether? 6 electrons for bonding. Two here, two here, two here, making 6 electrons. And how do you keep track? Now, remember in the previous slide where we were having 26 electrons, but now we've used 6 electrons out of 26, remaining 20 electrons. So we're going to deal with the 20 electrons in the next slide. So if you see the next slide, now you have to complete the octets around all atoms bonded to the central atom. Phosphorus is the central atom. Now, if you can't, let's start from chlorine. If you can't for chlorine, before you can obey octets, how many electrons do you need? You need 8 electrons. So let's count for chlorine. It's going to be 1, 2, 3, 4, 5, 6. Remember that this line means 2 electrons. So you can count everything for chlorine. 6, 7, 8. That means this chlorine is complete. It has obeyed octet rule. The same thing is also applicable to this chlorine. Same thing is also applicable to this chlorine. But now, let's check our central atom. How many electrons do we have around the central atom? Is it 8? Let's see. Remember, this is 2 electrons, this is 2 electrons, this is 2 electrons. That means we are only having 6, remaining 2 electrons. So if you can see, if you are keeping the tracks of the electron, we have 1, 2, 3, 4, 5, 6, 6, 12, then 18. That means we're going to subtract 18, 20 minus 18, that is going to give us the 2 electron that is remaining. So that 2 electron, it's what we're going to put here on phosphorus. Now, let's scan phosphorus and see if it's going to obey octet rule. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So all atoms in this compound have obeyed the octet rule because they all have 8 electrons now in their atomos shell. One thing to remember is this bond you're seeing is as a result of the pair electron, and pair electron means 2 electrons. So if you can't, you see it's 8, 1, 2, 3, 4, 5, 6, 7, 8. So you're going to count it as 2 electrons. So at the end, you're going to have 0 electrons. So all the electrons have been represented on the Lewis structure. So this is a typical example of Lewis structure. Now, let's move to chemical bonding. And why do atoms bond? Why do they want to bond? So atoms undergo chemical bonding in an attempt to fill electron shells and be stable. Remember the last lecture that we had that there are empty spaces in the atomos shell. When the atomos shell is not complete, it's not 8 electrons, that means you're going to have some empty shells that need to be filled before the atom can be stable. So we have 3 major types of chemical bond. The first one is ionic bond. Ionic bond is as a result of transfer of electrons from metal to a non-metal. And if you remember in our previous lecture, we discussed cations. Cations means you are losing electron. You are giving out the electrons. And anion means that you are gaining electron. That means that the electron that is being lost by metal is going to be gained by non-metal. So when you have a compound like that, they're going to form what we call ionic bonding. The next one is covalent bonding. Covalent bonding occurs by sharing of electrons. Sharing, that means the constituent, the atoms that are coming together, they're going to be ready to share their electrons. It's not that one is going to be given the electrons straight. away. The two of them are going to come together to share the electrons, and that is what we call the type of bond that is going to form as a result of sharing of electron is what we call covalent bonding. And the last one is what we call metallic bonding. These are the bonding that we find in metals. They hold metals atom together strongly together. So let's take them one by one. Ionic bonding. Ionic bond is as a result of electron transfer. So when, for example, see, sodium is transferring, remember the electron dot configuration of sodium. It's only going to have one dot. It's going to have one dot. So that one dot is ready to give away. So when it gives it away to chlorine that is expecting one electron to be complete, then you have what we call sodium chloride. So sodium is going to be positive and chlorine is going to be balanced and have a negative charge. So ionic bond, electron from sodium is transferred to chlorine. This causes a charge imbalance in each atom. So sodium becomes Na plus. It has lost an electron, and chlorine becomes Cl minus. That means that it has gained an electron, and they are now charged ions. So we can represent this to make it clearer in what we call schematic shell representation. So let's see. This is sodium. Sodium is 281. It has one electron at the outermost shell. And chlorine is 287, which means at the outermost shell, chlorine is having 7 electrons. And there is one empty space that needs to be filled. A sodium atom is going to transfer the electron to chlorine. See, so when it transfers it, then the two of them can be balanced. Now, sodium ion have 8 electrons. It's complete. It has obeyed the octet rule. The same thing for chlorine ion. Chlorine ion now has 8 electrons in its outermost shell. It's also complete. It has obeyed octet rule, and that's why the two of them can react to form what we call sodium chloride. So you can see transferring the electron to chlorine, then you have sodium chloride. So the compounds that are formed as a result of ionic bonding, they're going to have some specific properties. And these properties are listed here. So ionic bonding occurs between metals and non-metal. I've said that with different electronegativity. So it's going to be from between metals and non-metals. So the bonds are formed as a result of electron transfer. Ionic bonding produces conductors because they are charged. They are made up of charged particles, negative and positive. And anytime you have something that has negative and positive, then it's going to conduct electricity, even heat. So ionic compounds, they are very hard and brittle. So they are hard and brittle. So ionic compounds, they have high boiling and high melting points. Examples are listed below. So learning check. Use the SSR, a schematic shell representation of ionic bonding to represent the formation of the following, the KCl and MgCl2. So practice this. The more you practice that, then the more you get used to how to use this representation to form to form this kind of compounds. Covalent bonding. Covalent bonding is as a result of sharing of electrons between atoms. So this is not about transfer. This is about sharing of electrons. For example, we have hydrogen coming together. Hydrogen has one electron. This also has one electron. So the two of them are going to come together to form the bond. You can see we are having a pair electron here, which can easily form the bond between the two hydrogen atoms. Same thing for chlorine. Chlorine has 7 electrons in its outermost shell. So which means it can share this one that is not paired up with this one that is also not paired up to form a bond between them. So each pair of shared electron constitute one chemical bond. So for example, this is going to be just one chemical bond, and this is going to be also one chemical bond. So we have types of covalent bonding. We have non-polar covalent bonding. This is when electrons are shared equally. You bring one electron, I bring one electron. You bring two, I bring two. The second one is covalent, polar covalent bonds. So this is when electrons are also shared, but they are shared unequally. So for example, you bring one, A brings one electron and B brings two electrons. So the electrons are shared unequally. So let's see another diagram. This is the formation of oxygen atom, where you have O plus O to give you O2. And they do this by sharing of electrons. For example, you can see that they have to share this electron together and then also share this electron together. By the time they finish sharing this electron, if you can't, you will discover that they're going to have 8 electrons each. This is going to be 1, 2, 3, 4, 5, 6, 7, 8. So if you also count for this, so you're gonna have 1, 2, 3, sorry, 1, 2, 3, 4, 5, 6, 7, and 8. So the two oxygen atoms are now having 8 electrons in their outermost shell, and that's why they can come together to form the O2. Now, a quick question here. How many bonds are they going to form? It's going to be 2 because they are bonding together with this and they're also bonding together with this. So if you see hydrogen, oxygen atoms, it's going to be O double bond O. That's going to be double bond between them. This is another example of water molecule. Water is H2O. So that means we're having 2 hydrogen and we're having 1 oxygen. So oxygen, of course, needs 2 electrons to obey the octet rule. So the 2 electrons are going to come from the 2 hydrogens. And at the end, you can see that it's going to have 1, 2, 3, 4, 5, 6, 7, and 8, which is it has obeyed the octet rule and it's stable. Again, if you count for hydrogen, hydrogen only needs 2 electrons to be stable, to obey octet rule. So you have 1, 2, because hydrogen only has a K shell, and K shell only needs 2 electrons. You can check that in our lecture 2. So water is a polar molecule because oxygen is more electronegative. We discussed that in our previous lecture than hydrogen, and therefore electrons are pulled together to the oxygen. So covalent bonds also have properties. So they are formed between non-metallic elements of similar electronegativity. They form by sharing of electrons. So they don't ionize. So that means they cannot conduct. They don't ionize into, say, negative and positive. That means they cannot they cannot conduct. So bonds in all polyatomic ions and diatomic ions, they are covalent bonding. So example is oxygen, CO2, ethane, and water. Learning check. So mention the types of covalent bonding and how many bonds will be formed for the following compounds. You can use SSR to explain your solutions. So what are the types of covalent bonding? You can check from our previous slide under types of covalent bonding. Then how many bonds? Remember, the number of bonds they're going to form is the number of the pair electron that they're sharing. Metallic bonding. So This is the last types of bonding that we're going to talk about. The chemical bonding that results from the attraction between metal atoms and its surrounding sea of electrons. So the outermost electrons are free to move between overlapping orbitals. This accounts for metal's ability to conduct heat and electricity. So this kind of bonding is majorly found in metals, and they have also properties. So they are formed between atoms of metallic elements. The bonding is the same in all directions, and they account for property of malleability. They are good conductors at all states. Lustrous, they have a high melting point. So example, we have sodium, iron, aluminium, and so on and so forth. Metals form alloys. So metals do not combine with metals. So they can form alloys, which is a solution of a metal in a metal. So example are steel, brass, and bronze. As you can see, the yellow is one type of a metal, then the red is another type of a metal. So if you bring the two of them together by force, then they're gonna come together to form what we call alloys. Learning check. So what type of bonding exists in the following compounds and elements? Give explanation to your answer. So you have to go back to the previous slide and try these exercises. So for library, please read about the constituents of steel, brass, and bronze. What are they made of? So thank you. This is the end of lecture 3. See you for lecture 4.